Hi, I'm Paul Damon-Tucker, the Engineering Director here at Bowman Power Group.
Tell us how the ETC system actually works.
Well, basically it works in two main ways. First of all, we have to take the energy from the hot exhaust gases, which we do in exactly the same way as a turbocharger does. But instead of using that energy to compress air for the combustion in the engine, we convert that energy into electricity with the alternator part of the turbogenerator. In order to do that, we do have to do some work with the host engine's turbocharger, either by modification or replacement, just to make sure the whole pressure balance in the engine is correct for the engine's operation after we've fitted the ETC system. Once we've generated that electricity, we then have to condition it because it's very high frequency AC power that we produce, and we have a power electronics module which will convert that into grid quality 3-phase electrical power. So whilst our ETC technology is unique in the marketplace at the current time, it's entirely based on long-standing principles and technologies which have been around since the early part of the last century. Turbo machinery is something that we find in every modern day car or diesel engine. Electric machines, such as you see in vacuum cleaners and precision drilling, high-speed electric machines. And power conversion technology such as we have in wind power and solar power these days. As I said, the technology goes back to the early part of the last century, where people were working hard to improve aircraft engine efficiency with mechanical turbo compounding. And here at Bowman we've been building on those principles over the last 10 years, trying to bring modern technologies to play to have a commercially viable product in the marketplace.
So how does the technology differ from other solutions that are currently available in the market?
Well, we're doing something quite specific in terms of our technology being a waste heat recovery technology. The engine manufacturers clearly have been working since they started on improving engine efficiency, but the technologies as they introduce them tend to only make marginal gains at each stage. Waste heat recovery has the opportunity or the potential to make a step change in the engine performance. And ours isn't the only approach to that which you can take. Probably our nearest competitors, organic Rankine cycle or ORC, but it's not as compact as our solution. It's more difficult to install, it's more costly, and certainly we don't feel it has the track record that we have in the field in terms of operational units. We've got over 600 systems in operation, over 12 million running hours, and certainly our cost point is such that we can offer, in good circumstances, less than a 2-year payback.
Do you see other applications for this technology? Are there other markets that you might explore in the future?
Well, our focus is very much on the stationary power gen industry at the moment. That's where we see the highest duty cycle of the engines in terms of running hours per year, and therefore as a consequence highest fuel use, highest costs, even with fluctuating oil prices, and highest CO2 emissions. So the potential is strong for the technology in that sector. But we do see great potential for the technology in other sectors as well. Maritime's probably the nearest in terms of also having high load factors and duty cycles. And in fact, we have started a project already looking at transitioning the ETC technology from the land-based sector into the maritime domain. And we've got some government funding to support that, and we're working with a number of partners on taking that technology forward.